We'll be starting with the class then.
Yes, sir. We can start.
Okay, perfect. Sure. Let's start. I hope the audio and visuals are perfectly fine. So yeah, keeping this in mind, let's start with the class. Okay, I hope you can all see the screen, right? Yes. I hope the screen is visible to everyone. So yes, uh, hello, yeah, this side Dr. Abhijeet, and you all know that we have started with this exam mastery live classes from by the Oracle, right? So this class basically includes the rapid revision of all the important questions, all the important topics, okay, all the high yield topics, right? All the potent questions for exams, they are revised in a very quick manner, crisp, concise, right? And it is beneficial for all the students who are appearing for the upcoming university exams, even for the upcoming FMG and NEET PG, right? Apart from that, guys, you we are going to discuss these topics today, right? So the very first or a 10 marks question that is being asked in the exam multiple number of times, that is glycogenolysis and glycogenesis. Now, let us first start with the 10 marks question, and then we'll come to the short question answers, right? So the very first one, that is the glycogen metabolism, glycogenesis and glycogenolysis. Let's start with that, guys. Now, guys, you already know that if we talk about the glycogen glycogen, it is the storage form of, yes, storage form of glucose in our body. You already know that it is the storage form of glucose in our body, right? It is the storage form of glucose in our body. Or in other words, I can simply say that glycogen, it is the polymer of glucose. Polymer of glucose. You already know that it is a branched polymer of glucose. Now, this glycogen, it is made up of glucose units, right? Now let me write down these are the glucose units, right? So the glycogen is made up of these glucose units, not in a straight fashion, guys. We have branching points also, right? We have branching points also, right? It's a branch polymer. So you can easily see, yes. So this structure, it is basically the structure of the glycogen. It is the structure of the glycogen. So you can see that branching is present, right? Now, guys, remember over here, two important things that I want to highlight. Now, this structure, it is the structure of glycogen. Now, this glycogen, it is made up of these glucose units, right? Now, the bond present in between the glucose units, right? I have already discussed in the very first class, it is alpha 1 to 4 linkage, right? Or कौन सी linkage है? Glycosidic linkage, the covalent bond, right? It is alpha 1 to 4 linkage. But specifically, if I talk about the branching wala point, okay, this branching, where exactly the branching is present, the first point over here, where the branching is there, over here, the linkage, it is alpha 1 to 6. Alpha 1 to 6 linkage, right? So that is something you have to remember. In a straight chain, it will be alpha 1 to 4, but only at the branching point, the linkage, it is alpha 1 to 6, right? One glucose, the carbon 1 is involved, the aldehyde group, and the other one, that is the sixth carbon, CH2OH, right? Now, you already know that, okay, let me just give you a brief idea over here. What is this metabolism, guys? You already know that we are consuming the this. disaccharides or the carbohydrate rich diet, right? We are consuming carbohydrate rich diet in the form of, yes, disaccharides, right? Maltose, sucrose, lactose, right? Now, this maltose, sucrose, lactose will be broken down into glucose, will be broken down into glucose, galactose, and fructose. Right now, I'm talking about this glucose. This glucose will go into liver, right? It will go into liver. Now, in the liver, this glucose, right, it will go via portal vein, it will go into liver. This glucose, okay, will be converted into glycogen. This process is called as glycogenesis. Glycogenesis, glycogen का बनना, formation of glycogen. Ultimately, whenever there is a fasting state, guys, right, the early fasting stage, the stored glycogen, when you're not eating anything after 4 hours of food, right? See, we have a fed state and we have early fasting. Early fasting. Fed state is normally 1 to 4 hours after food. 1 to 4 hours after food, and early fasting it is 4 to 16 hours. In this early fasting, you are not eating anything, but still the blood glucose level is maintained. But still the blood glucose level is maintained only via one thing, that the stored glycogen will be now broken down to form glucose to provide energy. And breakdown of glycogen, it is called as glycogenolysis. It is called as glycogenolysis. Lysis means breakdown. किसका breakdown? Glycogen का. Glycogenolysis. So these two processes we have to see how glycogen is formed from glucose and how glucose is formed from glycogen, right? So that is yes. So that is something that you guys have to remember. Apart from that, you already know the glycogen, it is stored in two forms in our body. The glycogen, it is stored in two forms in our body. The storage of glycogen, the storage of glycogen, it is in liver and also in the muscle, right? Very, very important, right? Now, in the liver, it is highest percentage by tissue weight, highest percentage by tissue weight. Okay. And in the muscle, it is highest total body content. Muscles are present everywhere, right? So it is the highest total body content of glycogen in the muscle. अगर सिर्फ टिश्यू के हिसाब से देखोगे तो सबसे ज्यादा लिवर में है, बट ओवरऑल बॉडी की बात करें, so we have more muscles, so there is more glycogen. Highest total body content of glycogen in the muscle, right? So the storage of glycogen, it is basically in the two places, right? Now, coming on to the two definitions, guys. Now, if we talk about the glycogen metabolism, you should know, guys, that it is of two types, right? We have already discussed it is glycogenesis and glycogenolysis. Now, when we say glycogenesis, guys, formation of glycogen from glucose. The very simple definition, guys. The very simple definition, it is formation of glycogen from glucose. Formation of glycogen from glucose, and glycogenolysis means glycogen is broken down to form glucose. Glycogen, it is broken down to form glucose, right? Now, this glycogenesis, I've already told you, glycogen कब बनेगा body में? When you have taken a lot of sugar, when you have taken a carbohydrate rich diet, okay, when you have eaten 2-3 chapatis, what will happen? Right, it is in the normal fed state. Now, when I say fed state, it is usually 1 to 4 hours after food. When you have eaten a lot, so the extra glucose will be No, forced to form the glycogen, and glycogen will be stored in the body, right? And this glycogenolysis, it basically occurs in the fasting state. And which fasting? It is the early fasting, guys. It is usually 4 to 16 hours after food. 4 to 16 hours after food, and it is 1 to 4 hours after food, right? So that is about the basic difference between glycogenesis and the glycogenolysis. Now, guys, coming on to the next one, that is the let's start with one of the processes over here, that is glycogenesis. Glycogenesis. Now, when I say glycogenesis, means glycogen synthesis, right? It is glycogen synthesis. Right? Now, okay, let me explain you one concept over here. Now, why the storage form of carbohydrate is not glucose? Why glucose is supposed to form glycogen, beta? Why the body cannot store glucose? That is again a very important practical viva question that the examiner can put up you. Why glucose is not stored in the body? Now, if let us suppose a condition, beta. If suppose the glucose, why there is a need of glycogenesis, why there is a need of formation of glycogen, why body cannot store glucose? That is one of the reason that you guys have to remember right now. Now, if remember, beta, if glucose, okay, is stored inside the cell, let us imagine this condition. If glucose is stored inside the cell, what will happen? Now, glucose requires a lot of space. Okay, it's a linear molecule. It's not a branch molecule. It will require a lot of space. And remember, beta, that glucose, it is water soluble. It is water soluble. Now, water soluble glucose, okay, when it will, okay, now this water soluble glucose, now what the cell will do? The cell will absorb, right, this extra glucose from the extracellular matrix. Extracellular matrix. Now, what will happen when the cell absorbs the glucose from everywhere? The cell will be swelled up. The cell will be swelled up, right? So that is one of the reasons, guys. It requires a lot of space in the body to store. Secondly, the glucose, it is water soluble. Okay, whenever the no cell will try to absorb the glucose from the extracellular matrix, now extracellular matrix, all the fluid will come up in the cell, and the cell will become swollen. Okay, so yes. So what happens, beta? Now you already know, if we have this cell, the cell is automatically having glucose. So this glucose will also attract the water from the the fluid from the extracellular matrix, and the cell becomes swelled up. Right? Now, again, why glycogen genesis is okay. Now, if body needs glucose, if body needs glucose, the glycogen breaks down very, very fast at branching points, right? So glycogenolysis will take place. Okay. Now this glycogenolysis occurs fastly at the branching points. Glycogen is a branch polymer, branching point. Jaldi jaldi टूटना start करता है at branching points, right? Now, glucose releasing from the branching point, it is very fast. Glucose releasing from the branching point is very fast. Glucose releasing from the branching point is very fast, right? So that is something you guys have to remember. Now, now, glycogen synthesis, guys. Glycogen synthesis, basically, it occurs in the fed state. And which hormone in the fed state, guys? You already know it is insulin. I've already discussed this earlier also, right? Insulin, right? Now, what happens now? This glycogen synthesis or glycogenesis, right? It has, okay, the next question is what is the site? What is the site of glycogen synthesis? I've already told you it occurs in the liver. Yes, it occurs in the liver and it also occurs in the muscle, right? Again, which organelle? The next question, next Viva question, which organelle? Which cell organelle, right? Which organelle it is? That is the cytoplasm of the cell. Cytoplasm of the cell, it is the place where the glycogenesis will take place, right? Now, let us just talk about the steps of glycogenesis. Steps of glycogenesis. Steps of glycogenesis. The very first step, we have three steps, Peter. We have three steps. The very first step, it is the synthesis of UDP glucose. I will be teaching each step in detail, so no need to worry. Synthesis of UDP glucose. Okay. Then we have the reaction of glycogen synthase. Very, very important. Reaction of glycogen synthase. I will be teaching each and everything, so no need to worry. Just write down the three main headings, and we have the steps of branching. Steps of branching, right? Now, let us just understand one by one each and everything. So the very first step, guys, you already know that for the synthesis of glycogen always requires a primer. Okay, glycogen always requires a primer. So remember, beta, that glycogen is always synthesized. It is always synthesized on a primer. It is always synthesized on a primer. Now this primer, it is in the form of very, very important. It is glycogenin. It is glycogenin, right? It is glycogenin. Now glycogenin is nothing but beta, it is a polypeptide. Now जब भी हम polypeptide बोलते हैं, poly का मतलब many, peptide means peptide bond, right? Polypeptide is nothing but the protein. So this glycogen always requires a protein, and that protein, it is the polypeptide. It is nothing but the glycogenin. It is nothing but the glycogenin. Okay. Now this, if I'm saying protein, protein किसका बना होता है? Amino acids. Now which amino acid over here it is required? That is a lot of tyrosine residues. Again, a very important Viva question. Glycogen is always synthesized on which primer? Glycogen. And glycogen, it is made up of lot of tyrosine residues. Tyrosine, again, the amino acid, right? Right? So that is always that you have to remember, beta, right? Now, the very first step, guys, the very first step, it is written synthesis of UDP glucose. Now let us just try to understand this. What does this mean? Synthesis of UDP glucose. Just try to write it in the same way I'm writing over here on the screen. Okay, just try to explain the examiner in the same way. Now, beta, the very first step, you already know we have something called as the glucose. Glycogenesis means from glucose, what will be formed? Glycogen, right? Glycogen. So let us start with the glucose first. You already know glucose, it is a 6-carbon compound, right? It is a 6-carbon compound, right? Now to this glucose, what happens? The very first step remains the same. This glucose will change into glucose 6-phosphate. It means that the 6th carbon will have phosphate group. Now this phosphate, the first step, beta, it is the ATP will be used adenosine triphosphate. It has 3 phosphate. It is converting into adenosine diphosphate. It means that this ATP, it is giving 1 phosphate. Okay, it is giving 1 phosphate to the 6th carbon. So to the 6th carbon, phosphate will be added. Now, transfer of phosphate from one molecule, from ATP to glucose. There are two different molecules. One is ATP, one is glucose. And phosphate group, it is going from ATP to glucose. It is which enzyme? Hexokinase. Very, very important. It is hexokinase, right? And which ion it is required? That is magnesium 2 plus. Very, very two important questions in the very first step. So the first reaction, again, remember the glycolysis, it is same. So I always told you glucose 6-phosphate has two fates. It can go into glycolysis also, and it can go into glycogen synthesis also, right? Now it is glucose 6-phosphate. Okay, glucose 6-phosphate. Now glucose 6-phosphate, what will happen? Now this glucose 6-phosphate will be now changing into glucose 1-phosphate. Now this phosphate, which is present at 6th carbon, will now try to come at which position? First carbon. Will now try to come at first carbon. Now the glucose molecule is same. The transfer of phosphate group is in the same molecule, is in the same compound. There are no two different compounds. That means that the enzyme over here, which will be used, that is mutase. I have already told you mutase is an enzyme where one phosphate group will be transferred. Okay. See, the compound is same, glucose, glucose. Earlier, the glucose was present at 6 carbon. Now the glucose is present at first carbon. Only the shifting of the phosphate molecule has taken place in the same compound. So anywhere, if a company, the phosphate group is moving from one position to another, that is mutase. But if there are two different compounds like ATP and glucose, two different compounds, then it is kinase, right? So understand the difference between the enzymes that we are using, guys, right? So here we have mutase, and over here, beta, over here, remember, it is phosphomutase. Okay, it is phosphoglucomutase. ऑब्वियसली फॉस्फेट ग्रुप है तो बेटा फॉस्फो हो जाएगा, और ग्लूकोज है तो ग्लूको हो जाएगा, फॉस्फोग्लूकोम्यूटेस, राइट? फॉस्फोग्लूकोम्यूटेस. नाउ अब इसमें क्या हो गया? वी हैव 6 कार्बन्स, 1 2 3 4 5 6, and now the phosphate group, it is transferred to which carbon? First carbon. The phosphate group, it is transferred to the first carbon, guys, right? Now now Now, there is something called as, which is present inside the cytosol, that is called as the UTP. अब UTP क्या होता है? UTP is not U. UPT नहीं बता रहा हूँ, यूरिन प्रेगनेंसी टेस्ट नहीं बता रहा हूँ, UTP है ये. This is UTP. It is uridine ट्राइफॉस्फेट. यूरासिल होता है ना उसमें, आरएनए वाले में, ठीक है ना? So it is uridine triphosphate. Uridine triphosphate. Now what will happen? Uridine triphosphate. Now this UTP will combine with this glucose 1-phosphate. Now what will happen, guys? What will happen? Now let me just show you it on the next slide. We have glucose 1-phosphate. Okay, we have glucose 1-phosphate combining with UTP, uridine triphosphate. Now, when these two will combine, what will happen? There will be one inorganic phosphate, or one phosphate will come out. Okay, that is the pyrophosphate. UTP say phosphate. Okay. Dekho, there will be two phosphate coming out. One phosphate will come from the glucose and one phosphate from UTP. Now UTP से एक phosphate, it is uridine triphosphate. It is uridine triphosphate. What will happen if one phosphate comes out? So ये क्या बन जाएगा? UDP, uridine triphosphate, uridine diphosphate, and you already know this glucose was having phosphate. Now this phosphate is also removed. Two phosphates are removed. So only glucose is left. So what will be the product? UDP glucose. UDP glucose. And this PPI is nothing but pyrophosphate. Two phosphate molecules. One from the glucose it is removed, right? And one from the UTP it is removed. So UTP try से di बन जाएगा 3 से 2 uridine diphosphate glucose. Uridine diphosphate glucose. So I hope the first step it is very much clear, guys. That is the synthesis of the UDP glucose. That is synthesis of UDP glucose. Now, I hope this is clear. Sarath, I hope you are listening. I hope it is clear. Just give me a thumbs up if it is clear to you, beta. Now, coming on to the next one. Yes. The next step, guys. The next step says reaction of glycogen synthase. So write down the reaction of glycogen synthase. Reaction of glycogen synthase. Now, guys, you already know we have a primer, right? Let us just draw that primer over here. We have a primer over here. And this primer, it is nothing but it is containing glycogenin, right? It is containing one protein that is called as glycogenin. This glycogenin, it is a polypeptide. It is a protein which is made up of lots of tyrosine residues, right? Now what will happen? We have stopped our reaction over here, UDP glucose. Now this UDP glucose will be reacting with this glycogenin, right? So let us just try to write this UDP glucose over here, where we left. So we have so many UDP glucose which are formed. There are n numbers of multiple UDP glucose which are formed inside the cell, right? So we have UDP glucose. Now what will happen? There will be action of a very important enzyme over here, that is glycogen synthase, right? Glycogen synthase. We have action of glycogen synthase. And remember, guys, that this glycogen synthase, okay, it is the rate limiting enzyme. Very, very, very important. Exam pattern question, right? Viva question, the rate limiting enzyme for glycogenesis, it is the glycogen synthase. Rate limiting enzyme. Okay, and what is the function of this glycogen synthase? This glycogen synthase, what is the function? It transfers the okay, let me just write it for you. It transfers glucose from UDP glucose to glycogenin. Now we have UDP glucose. What will happen? Now this enzyme will act and it will transfer this glucose to this primer. It will transfer the glucose to this primer. So now let us just try to see over here what happens. So this is the glycogenin, right? We have the primer. We have this primer, and this primer it is having glycogenin. Now to this, what is adding? Glucose is adding. That is what is the action of glycogen synthase. Now to this, what is adding? This glucose is adding over here. So let me just try to draw the glucose over here. So yes, we have a lot number of glucose molecules, right? We have a lot number of glucose molecules which are added. N number of glucose molecules. It can be multiple number of glucose molecules, right? Just try to draw like this, right? So this glucose will be added to the glycogenin by the action of glycogen synthase. Now, what is the bond present between glucose and glucose over here? Yes, it is alpha 1,4 glycosidic bond. Alpha 1,4 glycosidic bond, right? Or glycosidic linkage, right? Now, that is the action of glycogen synthase. Now, what will happen? what will happen? Now we have something called as the branching enzyme. So let us discuss the third step, that is the steps of branching. Steps of branching. The third step, that is the steps of branching. Now, we already know we have a primer over here, that is glycogenin, right? This is glycogenin. Now, to this, what is added? You already know we have a lot of glucose molecules, right? Let us just try to draw like this. Now, what happens, guys? Just try to number it. Now, in the steps of branching, we have an enzyme that is very, very important, and that is called as the branching enzyme. Branching enzyme, which will act now. Now, what is this branching enzyme, beta? It is alpha 1,4, alpha 1,4, alpha 1,6 glucan transferase. Very, very important. Alpha 1,4, alpha 1,6 glucan transferase. Right? Alpha 1,4, alpha 1,6 glucan transferase. Now, what will happen, guys? It will cut the glucose from the last. Now, let us just try to number this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Now, for example, I've taken 12 glucose. From the last, it will cut up till 6 glucose. This enzyme will now cut up till the 6 glucose, right? And this one will come and add over here. This whole part, right? This whole part will come and add over the second carbon over here, the second glucose over here. So ultimately, the reaction looks like this, guys. Now, this is how. Okay, so this is right. Let me just draw with the same color so that you don't confuse, guys. Right. So you already know we have this glycogenin. We have this glycogenin, right? And to this glycogenin, you guys already know we have this. Yes. Now, what will happen to the second carbon? 1, 2, 3, 4, 5, 6, right? To the second carbon, what will be attached? All these will be attached. The 6 glucose will be attached over here. So this is like this, and this branching is created with the help of this enzyme glucan transferase. So this is how the glycogen will be formed. This is how the glycogen will be formed. So that is about the steps of glycogenesis. That is the steps of glycogenesis, right? So that is guys, you have to remember over here the steps of glycogenesis. Already I have told you in the muscle as well as the liver, the glycogen, it is stored as the beta particles, right? One beta particle, beta, remember it is about 60,000 glucose units, right? 60,000 glucose residues are there, right? Now, in the liver, the density of no, it is very much more. You already know the aggregates of beta particle are stored over there. So automatically the density becomes very, very more. Okay, so it is more in the liver. So we have already discussed glycogenesis, guys. I hope you all understand all the definition I've told you, the hormonal actions which are there. Okay, the sites, the organelle, and the steps. Now coming on next on to the glycogenolysis. 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 Now, what is the concept, guys, over here? The glycogen, it is broken down to form glucose. The glycogen, it is broken down to form glucose, right? Breakdown occurs. Breakdown occurs, and then glucose is formed. So it usually occurs in the early fasting stage. Early fasting stage, usually it is 4 to 16 hours after food. 4 to 16 hours after food, right? The hormone which is responsible over here, It is glucagon. Very, very important. Glucagon. Glucagon. Right? Okay. And it occurs in the liver. So it is liver glycogenolysis. Liver glycogenolysis. In the glycogenesis, insulin is activated. Over here, the glucagon is there. What is the function of glucagon? To break down the glycogen to release glucose. Now, again, the two things that are required over here. What is the site? Okay. The site, it means the organs, right? And we have to talk about the organelle also. So you already know it again remains the same. The organs are nothing but the liver along with the muscle, and the organelles are nothing but the cytoplasm. Cytoplasm. Again, one more thing, the examiner, if the examiner is very tricky, he will try to ask you one more question over here. 1 to 2% of glycogenolysis, it occurs in the lysosomes. It occurs in the lysosomes, right? It occurs in the lysosomes, right? Now, the cytostem, the organs, organelle, the hormone which is active, what is the definition, concept, and definition. So all this in a very short form we have discussed. Other things, they are all curated in a very good format in the notes in the Auricle app. Just go to the Play Store and download it, right? You will have an access to all the important points there as well. So just be with my notes and that notes. That's it, right? Now coming on to the steps of glycogenolysis. The steps of glycogenolysis, right? The glycogenolysis. What are the steps of glycogenolysis? Now, the very first one, guys, there are three steps that have to be like you have to study. The very first one, it is the action of glycogen phosphorylase. Action of glycogen phosphorylase. Action of glycogen phosphorylase. The second one, yes, the removal of branches. The removal of branches. And the third one, guys, conversion of glucose 1 phosphate to glucose. Conversion of glucose 1 phosphate to glucose. So from glycogen, we'll be forming the glucose. Now let us discuss one by one all the important steps over here. The very first one, it is action of glycogen phosphorylase. Action of glycogen phosphorylase. Now, you already know where we left actually in the last. We left at this particular stage. Now let us just try to draw the same stage over here. Okay, we are forming. Now let us suppose that this is the glycogenin, right? This is glycogenin, that is the primer. That is a polypeptide that is made up of tyrosine residues. We have this glycogenin. Now to this glycogenin, guys, you already know we have these glucose molecules, right? We have these glucose molecules 1, 2, 3, 4, 5, 6. And I already told you we have 6 molecules which were added to this, right? 3, 4, 5, and 6. Now, what will happen? What will happen? There is an enzyme present over here that is glycogen phosphorylase. Glycogen phosphorylase. Phosphorylase. Now, what this glycogen phosphorylase will do, okay, first very important thing that is being asked, what is the rate limiting enzyme in glycogenolysis? That is, you have to remember the rate limiting enzyme in glycogenolysis. Now, what it will do, now this glycogen phosphorylase, it will cut the alpha 1,4 linkage one from the ends. From here, from the branching points like this, it will try to cut Okay, so what is the first step it is doing? It is cutting. Okay, it cuts the alpha 1,4 glycidic linkage. Okay, one after another from end. One after another from end. Now, that is something. Now, remember, guys, this particular hormone acts only up to a limit of 4 glucose units. Only, okay? So remember, it only acts up to a length of 4 glucose molecules. 4 glucose molecules, right? From branching point and then stops. Okay, so from the branching point 1, 2, 3, 4, so it will cut 1 glucose, and then after 4 glucose are cut down, it will stop, right? Now that is something you have to remember. Now glycogen phosphorylase, again another important question that is being asked in the exam. This glycogen phosphorylase, basically it needs an enzyme, coenzyme, and it is nothing but vitamin B6. So this glycogen phosphorylase needs a coenzyme that is vitamin B6. It is nothing but pyridoxal phosphate, right? Pyridoxal phosphate. It's also known as PLP, pyridoxal phosphate, right? Vitamin uh, B6. And remember one more question that is being asked in the exam, where this highest content of pyridoxal phosphate is present. Again, one important, very important Viva question, this highest content of PLP, the highest content of PLP, it is present in the muscle. Very, very important. It is present in the muscle, and it is approximately 80%. It is approximately 80%. Now, after that, guys, what is formed? Glucose will be released. Yes, glucose will be released. So this glycogen phosphorylase will, yeah. So the glucose released over here will be glucose 1 phosphate. Glucose 1 phosphate, right? Glucose 1 phosphate. Now, जो भी ये ग्लूकोज रिलीज हो रहा है, it is not a free glucose, it is glucose 1 phosphate, right? Now coming on to the next step, guys, that is the removal of branches. Removal of branches, and remember it is the debranching enzyme. The debranching enzyme, and remember the debranching enzyme, it is a bifunctional enzyme. It is a bifunctional enzyme. Again, this is important. You have to remember that the debranching enzyme, it has dual functions to play, right? It has dual functions to play over here. Now, it is alpha 1,6 glucosidase and alpha 1,4 glucan transferase. Important, right? So it is a debranching enzyme, right? It is a bifunctional enzyme. Now, what will happen? Now, this glucan transferase, guys, what it will do? Let us just try to see over here. What happens, guys? You already know we have a glycogenin over here, right? Now, what is left? After these, this is cut. If this is removed, what is left? Glycogenin. Let us draw this glycogenin now. Glycogenin. Now, to this glycogenin, 6 glucose units are present over here. You can see these 6 glucose units, right? Let us just try to draw this. 1, 2, 3, 4, 5, and 6. Now, we have how many glucose units which were left over here? You can just count, right? two are left over here, right? Or let us take some more glucose units just to make you more understanding, right? 1, 2, 3, 4, right? Let us just say 4 are left for a change, right? Now what will happen, guys? Just to explain you people, remember that yes. Now glucan transferase will cut a trisaccharide. These are three glucose units. This is nothing but trisaccharide. Three sugar units are there. So this is basically cut by an enzyme that is alpha 1414 glucan transferase. So it is alpha 14. Write down complete name. It is alpha 14. Okay, let me just write it. Alpha 1414 glucan transferase. Now this enzyme cuts a trisaccharide. Alpha 1414 glucan transferase basically cuts a trisaccharide. Right? Right? So that is actually the alpha 14 linkage is present, right? Alpha 14 linkage is present. After that, what will be formed? What will be formed? You already know we have this glycogenin, right? We have this glycogenin. Now this glycogenin will have these glucose units over here. 1, 2, 3, 4, 5, 6. And only one glucose is left over here right now at the branching point. So here which enzyme will act? That is alpha 16 glucosidase. Alpha 16 glucosidase will act over here and it will cut this branch. That is the alpha 16 linkage. Right? And glucose will be removed. And this glucose, it is the free glucose which will be removed, right? ये free glucose होता है, इसमें नहीं add होगा कुछ भी, right? This is the free glucose which is removed. And the third enzyme is glucose 1-phosphate. Now the majority of the glucose that is removed, it is glucose 1-phosphate. So how the glucose 1-phosphate is converted into glucose? The third step that you have to remember, guys, over here, that is the conversion of glucose 1-phosphate to glucose. So it is the major product, guys. It is the major product. And obviously, yeah, the phosphate group is removed. Phosphatase enzyme will be used. Okay, glucophosphatase will be used to remove and to convert yeah, remove the phosphate group, right? So remember, guys. Okay. So yes. Now, what will happen? How does this steps take place, guys? Let us just try to discuss in short. Okay, what happens in the liver, guys? What happens in the liver? You already know we have an enzyme. Okay, we have glucose 1-phosphate, right? Now, what happens to this glucose 1-phosphate? It will change into glucose 6-phosphate. Again, it is mutase. And which mutase? Because we have the same molecule, glucose, but the phosphate group, it will be shifting from first carbon to 6 carbon. So it is phosphoglucomutase. It is phosphoglucomutase, right? And this glucose 6-phosphate will be broken down to form glucose with the help of enzyme glucose 6-phosphatase. I've already told you when we have to remove a phosphate group completely, it is phosphatase. It is phosphatase. Okay, it is phosphatase, right? Now this glucose 6-phosphatase, it is present in, again, the locations are very, very important. It is present in the smooth endoplasmic reticulum. It is present in the smooth endoplasmic reticulum, right? Okay. Now this enzyme, it is common to, again, next Viva question, it is common to both glycogenolysis. Okay, we are discussing this enzyme in glycogenolysis right now over here. And we have also discussed this in gluconeogenesis when we are synthesizing glucose. In yesterday's topic, day before yesterday's topic, I have discussed this gluconeogenesis. Okay, gluconeogenesis, right? Okay, so that is something you guys have to remember. Okay, now Now, guys, remember one more important thing, that the liver, guys, it is a selfless organ, right? It is a selfless organ. It provides glucose to blood. It provides glucose to blood. Whereas when we talk about the muscle, guys, muscle is a selfish organ, right? The selfish part. Basically, it is using the glucose to form, to no it is using the glycogen or glucose for its own energy. That's why we call muscle a selfish organ, whereas the liver, because it is providing glucose to all the parts of the body, it is releasing the glucose in the bloodstream, and that blood it is going to different parts of the body. So liver is a selfless organ. The muscle is a selfish organ. Muscle is a selfish organ. Right. So that is something you guys have to remember over here. So that is all about the glycogenolysis and glycogenesis and glycogenolysis. So we have discussed the glycogenesis, all the steps of glycogenesis and glycogenolysis, the concept, the site, the organs, all the important actions, the rate limiting enzyme, how the function acts, right? And how it is taking place in the liver, all the series, all the steps and reactions are done. Now, Now, I hope you understood this. Just let me know, Sarath, if you are there, if you understood both the concepts clearly, right? So we have already discussed the glycogenolysis and glycogenesis. Now, before coming on to the HMP pathway, let us just try to discuss some important questions over here, guys. I'm using the notes from this Auricle app. They're beautifully curated. So I will be teaching these short questions from there only. Whatever I feel, no, there is a need of making you understand, I'll write it also, right? Now, glycogen storage disorders, guys. Very, very important. A short note question. How to remember, guys. Now, let us just, I want to tell you one mnemonic over here. That is A, B, C, D. Now, guys, come on to the fourth one. Type 4 glycogen storage disorder. It is Anderson's disease. Anderson's disease. A के बाद क्या आता है? B. It is absence of which enzyme? Branching enzyme. Absence of branching enzyme. You already know branching enzyme. It is used in the formation of glycogen. Glycogenesis. Where it is occurring? It is occurring in the liver. So remember AB. Anderson's disease, branching enzyme is deficient, right? Obviously branching कहाँ पढ़ा अभी हम लोगों ने? ग्लाइकोजेनेसिस में. ग्लाइकोजेनेसिस कहाँ होती है? लिवर में, राइट? अगर ब्रांचिंग एंजाइम नहीं होगा तो क्या होगा? एबनॉर्मल ग्लाइकोजन हो जाएगा, राइट? और अर्ली डेथ हो जाती है. बेसिकली देयर इज हार्ट फेलियर और लिवर फेलियर. लिवर में खराबी आ जाएगी. लिवर फेलियर, पर्सन विल डाई. Simple thing that is mentioned over here. Coming on to the next one, CD, guys. CD. Now you already know. Okay, coming on to the C. C, it is the Cory's disease. C वैसे भी third number पे आता है ना, third alphabet. A, B, C. Cory's disease. C के बाद क्या आता है? D. So absence of D branching enzyme. We just read it right now. Again, where it is happening? Liver and muscle. Skeletal muscle and heart. Liver, muscle. Again, you remember this, right? Glycogenolysis. Now, up there is no okay. If this enzyme is deficient, obviously glucose will not be able to form. There will be abnormal glycogen which will be having, right? So person, if it is not having glucose, it will result in hypoglycemia. Hypo means low, glycemia means glucose, emia means blood, low blood sugar, because glucose bun ही नहीं रहा. Obviously, debranching enzyme helps to break down the glucose at various points. Again, this point is not there. Only glycogen is there. Abnormal glycogen is getting accumulated. Glycogen cannot be used for making ATP. Glycogen first has to form glucose. Glucose bani nahi raha. So there will be low blood, glucose in the blood. Hypo, low glycemia, glucose, emia, blood. I hope ABCD you will never forget. Anderson disease, branching enzyme, liver, glycogen synthesis abnormal. C, Cory's disease, debranching enzyme, liver muscle. Again, yes, the same problem with the glycogen वाला part. Glucose नहीं बनेगा, hypoglycemia होगा पेशेंट में low blood sugar देखने को मिलेगा क्योंकि blood glucose आ ही नहीं रहा. Coming on to Pompey's disease. Pompey. One of my friend was Pompey. Yeah, glycogen storage disorder 2. Glycogen storage disorder 2. And you guys already know there is deficiency of lysosomal alpha 1,4 glucosidase, acid maltase, right? So the all organs with lysosomes. Yes, suicidal backs of the cells have, you guys have already discussed this in 11th class, right? Infantile form, early death, cardiac failure would be there, accumulation of glycogen in lysosome. I told you, like some part of glycogenolysis, no, they occur in, yeah, 20%, like they occur in lysosomes also. So that is Pompey's disease. Okay, Pompey's disease. Coming on to the very important, that is the von Gierke's disease, that is glucose 6 phosphatase. Now, guys, tell me, glucose 6 phosphatase ka kaam kya hai? What is the function of glucose 6 phosphatase? Now, if we have glucose 6 phosphate, glucose 6 phosphatase, phosphatase का काम क्या होता है बेटा? Phosphatase helps to remove the phosphate group. Now, remember, if this enzyme is not present, phosphatase is not there, glucose 6 phosphatase is not there, will glucose be glucose will be formed? No, glucose will never be formed, because for the formation of glucose, there is an enzyme, that is phosphatase, which is used to remove this phosphate group. Obviously, the glucose 6 phosphate will be more in the blood. Glucose तो बना ही नहीं. There is no glucose formed. Why no glucose? Because phosphate is not removed. Phosphate क्यों नहीं remove हुआ? क्योंकि the enzyme which removes the phosphate group, phosphatase, it is absent. So the person will have low blood sugar. The person will have low blood sugar, hypoglycemia, low glycemia, glucosemia, blood, lactic acidosis, hyperlipidemia, right? Ketosis, hyperuricemia. Okay, uric acid will be more in the blood, right? Now, coming on to the next one, guys, that is the McArdle syndrome. Okay, McArdle, Mc से याद रखना, muscle glycogen phosphorylase, right? Again, the skeletal muscles, right? So what will be happen? McArdle में muscle cramps देखने को मिलेंगे. Just remember the muscle cramps will be there. Okay, decrease serum lactate after exercise, right? Serum, yeah, the blood will have low lactate after exercise. Hirsch disease, deficiency of liver glycogen phosphorylase. Again, it occurs in the liver, right? And Tori's disease is deficiency of phosphofructokinase, PFK1. Glycolysis, guys, I've already discussed in muscle and erythrocytes, right? So what will happen, as in type 5, in addition to hemolytic anemia, I've already told you, if this enzyme is absent, phosphofructokinase, glycolysis will never take place. Glycolysis nahi hogi, there will be no, because RBCs are only dependent on glycolysis for the energy purpose, for the ATP. If no glycolysis will take place, what will happen, guys? What will happen? Again, there will be hemolytic anemia. The RBC will break down, all the hemoglobin will be like distorted, ruptured, बाहर निकल जाएगी RBC cell से. So again, there will be a less number of no RBCs, and that will result in the anemia wala part, right? So that is about the glycogen storage disorders in short. Just draw the same flowchart whenever this question comes. Coming on to the next question, guys. Coming on to the next question. Okay, before the pentose phosphate pathway, let us discuss a short note on the glycosylated hemoglobin, guys. Now, when I say glycosylated hemoglobin, you already know the HP, the protein part, right? The heme plus globin, right? Refers to sugar. Sugar may be kya? Mainly glucose attached to hemoglobin, HbA1. Most abundant form is HbA1c, right? Addition of sugar, it is directly proportional to blood glucose level. Now, HbA1c, it is normally 4 to 7%. Now, guys, again, the normal value, guys, it is not exactly 4 to 7%. It is approximately till 6.4, right? Exact values. More than this, basically, we classify it as diabetic. From 5.6 to 6.4, beta, it is pre-diabetic stage. It is pre-diabetic stage, right? More than this, actually, this HbA1c levels tells about the glucose intake in the last 3 months. In last 3 months, right? Now, what happens, guys, whenever a person comes to me and he is having uncontrolled diabetes, I always ask the patient to undergo a test that is called as HbA1c. Now, this HbA1c levels in the blood will give me an idea of the past three sugar intake in the body. So that is again very important for no diabetic people. We always do this HbA1c wala test, right? Now, what is the significance, guys? It measures the long-term blood glucose. I already told you minimum 3 months sugar intake would be okay. And glycosylated hemoglobin remains attached to RBCs throughout their 120-day lifespan. RBC ka lifespan kitna hota hai? 120 days, right? Now, it reflects the blood sugar level over approximately 60 days, or it is like, yeah, 3 months, beta, 90 days. According to the latest update, it is 90 days, right? Used for monitoring treatment responsible in diabetes. It is not for diagnosis, right? It only tells about the sugar intake in the last 3 months, right? Now, previous 2 to 3 months, poor diabetes control, levels below 7, or I would say 6.4 or 5.6 basically indicate that there is a good absorption of glucose in the blood. I mean, in the cells, right? Okay, so that is about the glycosylated hemoglobin. Now, coming on to the next question, what is lactose intolerance, right? Now, you already know the normal reaction, guys. Lactose, it is basically a disaccharide. Lactose is basically a disaccharide. Now, this lactose will be broken down to form glucose plus galactose. It will be broken down to form glucose plus galactose by the enzyme lactase, right? Now, what will happen? Now, lactase is present in the brush border. We have the epithelium over there, the brush border of enterocyte centric cells. Okay, it is present over there. If this lactase enzyme is deficient, guys, will the lactose be broken down to glucose and galactose? No. If this lactase enzyme is deficient, in this condition, lactose जो है body में accumulate होने लगेगा gut में, inside the whole gut, right? Now, what will happen? Diarrhea. Always know people say I'm lactose intolerant. No fancy people will know come and say that I'm lactose intolerant. I cannot digest lactose in this. Why? Because this lactase enzyme is deficient. If this lactase is deficient, glucose will never be formed. Glucose नहीं बनेगा, energy नहीं मिलेगी. लैक्टोज से तो एटीपी नहीं बन सकता ना, तो ऑटोमेटिकली द लैक्टोज गेट स्टार्ट डिपॉजिटेड इन द ब्लड, राइट? सो ये कंजेनाइटल भी हो सकता है, प्राइमरी, और इट कैन बी सेकेंडरी कॉजेस आल्सो, राइट? सो over here, just that is the lactase enzyme is not present. That's the only thing that you have to remember on the lactose intolerance, right? Now, coming on to the next question, that is what is the polyol pathway, right? Now, coming on to okay. Now, what is this polyol pathway, guys? Now, you already know we have this glucose, carbohydrate, and we have this alcohol, right? The all part. Okay. Now, what will happen whenever we are converting a carbohydrate into an alcohol group? What is there? Yes, the aldose reductase is used, right? And obviously, this alcohol getting converted into again the carbohydrate, it is sorbitol dehydrogenase. Sorbitol dehydrogenase. What is actually the polyol pathway? Basically, from the glucose, we are forming what? Fructose, right? Is formation of fructose from the glucose, right? This pathway is basically under normal conditions, right? Okay. Now, you already know fructose. Fructose is basically now formed in the seminal vesicles, right? नीचे जो है seminal vesicles में form होता है. It is basically providing energy to the sperm, right? To the sperm. So remember, now, what will happen if there is a disorder of polyol pathway? Now, what will happen if there is a disorder of polyol pathway? The glucose will never be able to convert into fructose. What will happen? Glucose will convert into sorbitol only. Sorbitol will never be able to convert into fructose. Now, what will happen? This sorbitol will accumulate in hyperglycemia. The blood sugar levels, okay, will be more, okay, because insulin is not required for entry of glucose into the cells, okay, such as retina, lens, and nerve. Large amounts of glucose may enter those during hyperglycemia. Like in uncontrolled diabetes, what will happen? These no glucose will get into the lens, into the retina. Okay, hyper का मतलब होता है ज्यादा, glycemia means emia means blood, and glycemia means the sugar, right? The sugar will be more in the blood. If sugar is more into the blood, the glucose will go into the retina and everything, the lens. Okay. So yes, if the glucose concentrations are increased, okay, and obviously the sorbitol will be there, so they will accumulate inside the cell, so they can cause osmotic damage, they can lead to the formation of cataract, okay, they can lead to the peripheral neuropathy, okay. Basically sensations will not be you diabetic patients are more often no prone to this peripheral neuropathy. If there is uncontrolled diabetes for a longer period of time, you'll see people having no sense I mean the they will not be able to sense, like the peripheral senses will be absent, retinopathy, the retina will be like yeah, distorted, okay, and nephropathy, the kidneys will be also suffer. So that is about the polyol pathway, guys, that you have to remember. After that, okay, now we have already discussed this, right? Now coming on to okay, let us okay. Now before pentose, okay, one topic is left, that is pentose phosphate, right? Yeah, pentose phosphate pathway or HMP pathway. Now let us just try to discuss this, guys, also. What is HMP pathway? Okay, let us just try to discuss this also. What is HMP pathway? Now, this is something that you guys have to remember from exam point of view. Firstly, only they have asked the significance, but I will first teach you the steps also. Significance already have taken the screenshot from your Oracle notes. So yeah, before that, I will be teaching you the steps, guys. So remember, guys, now let us just try to focus on these questions now. HMP pathway. It can be asked as a long question also, guys. It can be asked as a 5-mark question or 8 marks question as well. So remember, guys, HMP pathway stands for hexose monophosphate pathway. Monophosphate pathway. Right? Now, this HMP pathway, it is also known as pentose phosphate pathway. Pentose phosphate pathway, right? Or it is also known as Dickon Horecker or Ecker, write down like this. Dickon-Horecker pathway. So we have three names: hexose monophosphate pathway, pentose phosphate pathway, and Dickon-Horecker pathway. Now, what is okay? What is the site of this pathway, guys? This HMP pathway, the site, it is cytoplasm. It is cytoplasm or the cytosol. Now, remember, guys. Okay. Now let us just try to learn the steps first. Steps or phases of HMP pathway. Now we have oxidative phase and non-oxidative phase. Oxidative phase and non-oxidative phase. Oxidative phase and non-oxidative phase. Now let us just try to learn the difference first, then I will show you all the steps in detail. Now in the oxidative phase, guys, remember that this phase, it is an irreversible phase. It is an irreversible phase and it produces the major source, okay, that is the okay, or it produces NADPH. NADPH, nicotinamide adenine dinucleotide phosphate hydrogen, right? And non-oxidative phase, it is reversible and it produces pentosis. Pentosis. Now, when I say pentosis, guys, now this is the significance that you have to remember, guys. Now, when I say significance, very, very important. In one line, if I have to say, I will be teaching all the significance also. NADPH beta, it is basically no used for various purposes. It is used for biosynthesis of fatty acids. right? Biosynthesis of fatty acids. I will be discussing it in detail. Okay. For example, no, where the oxidative phase operates, it is liver, right? Adipose tissue, gonads, right? Even the ovaries, right? Apart from that, the mammary glands, the lactating mammary glands, especially, and the thyroid glands, they are all the places where no these the oxidation or reductive biosynthesis of these fatty acids will take place, right? I will be discussing all the significance, but these pentoses, guys, remember it is important for DNA and RNA synthesis, right? DNA and RNA synthesis. This is one of the major no significance of these fast pathway. So let us discuss the step and the significance simultaneously. So you don't forget it. Both the things will be done in one way or the other, right? So let us discuss the steps and the pathway simultaneously. Now, guys, now let us discuss the first, that is the oxidative pathway. So the first one, it is the oxidative pathway. Now, you guys already know we have something called as glucose. Glucose will be changing into glucose 6-phosphate. And I even don't need to tell you which enzyme will be used over here. Yes, it is ATP will be converting into ADP. We have 6 carbon in the glucose, and glucose 6-phosphate means the phosphate group will be added to the 6th carbon, right? Which enzyme it is used over here? Mg2 plus iron. And which enzyme? It is hexokinase. First step, right? Now, this glucose 6-phosphate will be changing into 6-phosphogluconate. 6-phosphogluconate, right? It's also 6 carbon compound. Now, what will happen, guys? Over here, yeah, the enzyme which will be used over here, it is glucose 6-phosphate dehydrogenase. Very, very, very important. Glucose 6-phosphate dehydrogenase. It is the rate limiting enzyme. It is the rate limiting enzyme over here. Very, very important. And this reaction, it is irreversible. The whole reactions are irreversible over here. Now, what will happen whenever a dehydrogenase is used, guys? You already know we have NAD plus changing into NADH, okay, or NADP plus, the phosphate group is there, NADPH plus H plus, right? So that is something you have to remember. After that, this 6-phosphogluconate will be changing into ribulose 5-phosphate. It's a 5 carbon compound. It means from a 6 carbon, 5 carbon is formed. So what happens? Again, there will be a loss of CO2 molecule. There will be a loss of CO2 molecule. 6 से 5 कार्बन में एक CO2 चला गया. Okay, again the dehydrogenase will be there. 6-phosphogluconate dehydrogenase. Dehydrogenase. And remember, again, whenever there is dehydrogenase, it is NADP plus. It will be forming NADPH plus H plus. So NADPH is formed, right? In this phase, NADPH is formed. Now, what is the significance of this NADPH? Significance of this NADPH. Now, the very first one, you already know it is reductive biosynthesis. Biosynthesis of fatty acids, okay, and steroids, okay. Steroids, even the cholesterol, right? Even the cholesterol. Okay. Now, where this oxidative phase operates, right? Where the reductive biosynthesis of these fatty acids takes place, it is liver, right? I've already told you we have adipose tissue. Adipose tissue. We have gonads. Okay, we have gonads like the ovaries, right? Lactating mammary glands. Lactating mammary glands. And remember one more thing, that is the thyroid glands. Thyroid glands. So again, a 1 mark question, they can ask you simply the organs where the oxidative phase operate. Organs where oxidative phase operates, it is what? Oxidative phase operate, it is this. So the first significance of NADPH, it is used for the reductive biosynthesis of fatty acids, steroids, and cholesterol. The second one, very, very, very important, it is used for, it is needed for free radical scavenging. Free radical scavenging. Okay, free radical scavenging. Basically, now what happens, guys, over here? I just wanted to tell you the H2O2 basically changes into H2O. Glutathione is there, right? So glutathione is basically oxidized, right? It is oxidized. And again, you already know we have the flavin adenine dinucleotide, right? It is, no, the NADPH basically converting into, yeah, NADP, NADP, right? So we have glutathione peroxidase over here, and glutathione reductase over here. The enzyme used over here, glutathione peroxidase, and over here it is glutathione reductase. Right? Now, what is free radical scavenging? Why this is important, guys? Why this is important? I just wanted to discuss it over here. I have space or not? I don't know. Let me just see. Yeah, okay. I'll teach you over here. Free radical scavenging. Free radical scavenging, guys, it is basically important in RBC to maintain membrane integrity. To maintain membrane integrity, okay, of RBC. Second, lens. Basically, to keep the transparency of lens. Right? And the third one, that is the HP. Okay? It does not allow the HP to change into methemoglobin. Fe+3, right? So yeah. So that is free radical scavenging. It is very, very important in erythrocytes. Right? Now coming on to the non-oxidative phase. Now, I'm only discussing about the non-oxidative phase in a very, very short manner. I've already discussed all the important points over here, right? Okay. The non-oxidative phase, guys. Remember the non-oxidative phase. I'm not discussing the reactions, but just remember, right? The non-oxidative phase, what it will be forming? It will be forming the pentoses. It will be forming the pentoses. So basically, this is occurring in all the organs. The pentoses are important for DNA and RNA synthesis. RNA synthesis, especially the skin, interstitial, or I can say the intestinal mucosa, and the bone marrow. And the bone marrow. So that is about the non-oxidative phase or the pentosis wala part. Right. So we have already discussed this. I've not discussed the non-oxidative phase in detail. You can just go through the notes, right? Rest all questions we have discussed in details, guys. So that's all for today, guys, right? So you can just have a look all the features of this particular app, the live classes, the recorded classes, the notes, MCQs, everything are curated in a very nice manner, guys, right? So you can use my code Dr. Abhijeet 20, right, to access no special discount to no for these apps, right? So the plans are already no, I'm sharing it on the screen. You can just have a look up to this. After that, yeah, let us just end the session over here. Thank you for your patience. Thank you for listening me out, right? So let's meet tomorrow, guys, with lipid part. Okay.